All right, everybody. So we have seen the in the last video you saw the SOHCAHTOA in action. It was dynamic. It was exciting. It was a little too much to handle because it was just in your face. All right, so there's an alternative way for using SOHCAHTOA. All right, so let's say that we've got that we're looking for an angle. Okay, so that is what this video is about. Now I'm looking for an angle, and therefore I know that the two things I know are sides. So maybe it's this is 10 inches and this is 15 inches. Okay, and what is the angle? Now, like I said before, the only thing you're allowed to plug into sine, cosine, and tangent are angles. So that's the way it's got to be. So I got to go I say, okay, relative to this angle, I know the adjacent. So the two sides I'm interested in are the adjacent and the opposite. Oh, I meant it to be something else. Oh, well, whatever. So the opposite and the adjacent, that means tangent. So I'll say, all right, let's go tangent of the angle, always the angle, equals opposite over adjacent. Yeah, that's right. Okay, so how do we handle that? I mean, this doesn't mean tangent times question mark. This has nothing to do with multiplication. All right, but like we always do, like you have, hey, I've got x squared equals 25. You say, well, I got to get the 2 away from the x. What's the opposite of squaring? Square root. And you just always do the opposite, right? So what's the opposite of tangent? That is a very good question. In fact, it is going to be what's called, I don't want to write there, what's called tangent inverse. The opposite of cosine is cosine inverse. The opposite of sine is sine inverse. And that -1 just designates it as the inverse function. It's the opposite function. So here's what it's going to look like. Okay. I'm going to do it the long way once. Let me move that over just a little. Okay. So I had 15 tenths. All right. So what I'm going to do is I'm going to go tangent inverse of both sides. Now this might, be like, this feels a little above my pay grade in terms of the algebra that I know. That's okay. You're not going to have to worry about, the subtleties and what's going on behind the curtain. Suffice to say, this is the opposite of this, and therefore these two cancel each other, and I'm just left with that on the left side. Okay, so how do I do tangent inverse of 15 tenths? Well, the good news is we're doing it on the calculator, and it's not too bad. Now, you'll notice right above the sine, cosine, and tangent buttons, there's the sine inverse function in blue, and the cosine inverse, and the tangent inverse, all of them in blue. So I'm going to go blue tangent of 15 tenths, like that, and the parentheses there above the 8 and the 9 keys. And I get that. Now, I should get an answer between 0 and 90 degrees, right? And I did, 56.3 degrees. That would be our answer for this one, 56.3 degrees. Let's try another one. But this time, I didn't erase the SOHCAHTOA sign. Whoops. Yeah. So that is, see, old dogs can learn new tricks. Okay, so let's do maybe something like this, I guess. And we're looking for that angle there. And so this time, I don't know where. We've got a 5 millimeters and 4 millimeters. And I'm picking these numbers so they work out real nice this time. Oh, well, If I was looking for this side, that would be 3 millimeters, the 3, 4, 5 right triangle. Okay, so this is the angle I'm interested in, obviously. And the two sides I'm playing around with are the opposite and the hypotenuse. That involves sine. All right. And why did I put the triangle that low? I don't know. Let's go. So sine of the angle is going to be equal to the opposite divided by the hypotenuse. And so now I'm going to do sine inverse of both sides and end up with sine inverse of 4/5, very similar to what we did last time. Okay. Okay, so let's go to the calculator, and I need blue sine inverse of 4/5, and I get 53.1 degrees, and that's it. Okay, one more. Okay, so on this one, let's go maybe something like this. Again, to do this trigonometry, just like the Pythagorean theorem, you need to have a right triangle. Okay. All right, so we're looking for this angle here, and we have got 12 angstroms. That's a really small unit measure. Frequently, it's used for really small things like how long is the light wave. And let's say 10 angstroms here. Oh, but wait, can't do that. Hypotenuse has to be longer, doesn't it? Okay. So we'll say 18 angstroms. How about that? Okay. So relative to this angle, the two sides we're interested in are the adjacent and the hypotenuse. So that involves cosine. So I'm going to say cosine of my angle, because you always plug in an angle into sine, cosine, and tangent, is going to be, what do we do? Oh yeah, the adjacent side divided by the hypotenuse, which is the exact same. Oh, no, it's not the same ratio. Okay. I'll do cosine inverse of both sides. Is that right? Yeah, that's pretty good. Okay. And so then I'll go to here and I'll say second cosine of 12/18 is 48.2 degrees. Okay, 48.2 degrees, and that's how big the angle is. And that is how this is all done. Okay. And of course, there'll be some subtleties in the homework, but this should really, really help move the ball down the field for you, these two videos. That's all I got.